Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about absolute value function, and we're going to graph them. When we graph an absolute value function, we have to know what it looks like. We need to know how to construct a table. We know what's the parent function, not parent functions. Parent function, the domain and range. We have to know the transformation. These are the shifting left or right, up or down, how steep the graph is, the shortcut technique. I'm going to share it to you today. And also, we're going to go with using table of values. So there will be two methods in graphing. And we're going to connect it with the piecewise functions. Okay? So let's go ahead now. So the absolute value function is written as f of x is equal to absolute value of x. Or for equation, you put y equals absolute value of x. That's the parent function of the absolute value. Okay. Complete the table below to graph the function, give the domain and range. So what you need to do, if the value of x is -3, you plug it into the x here inside absolute value. Absolute value of -3 will give you a 3. Everything inside the absolute value turns to be positive. Like in a football game, like you raise your hand, like an absolute value, it becomes positive because it's touchdown. Absolute value of -2 is +2. Absolute value of -1 is 1. Absolute value of 0, 0 is not a positive or negative. So an absolute value of 0 will remain 0. Absolute value of 1 is still going to be 1. Absolute value of 2 is 2, and absolute value of 3 is 3. So you will, after you make the table, you will plot the point, -3, 3, -2, 2, -1, 1, 0, 0, boom, boom, boom. And just by looking at the points here, we will connect them. And you can tell already by looking that the graph on absolute value is like a V-look, like shape, okay? Look like a V-shaped graph, okay? And when we go with the domain and range, look at the graph here. There's an arrowhead goes to the left and right. So that means the domain is all real numbers, or from -infinity to +infinity, or all real numbers. While the range, the lowest point of the graph is this value here. Remember, guys, this is -1, -2, -3, -4. And the range talks about the y. So if this is -4, -3, -2, -1, 0. So this is 0 here. So from 0 going up. So if that's 0 from going up, that means it's bracket 0 to the infinity. Or you can say also y is greater than or equal to 0. Okay? Either of these two is correct. But what happened when we have y is equal to absolute value of x, but there's a negative outside? This is where the transformation and the movement, the changes in the graph of absolute value. If you have a negative there, just by looking, let's see, looking at the graph here, obviously the table will be different now. If you have a negative outside, it will go opens downward now. It reflects over the x-axis. So every time you have a negative there, it bows down or it opens downward, okay? So the value on the table here will remain the same, except it will be negative because there's a negative outside. So this will be -3, -2, -1, 0, -1, -2, -3, okay? So the domain here is, again, it's from left to right, from all real numbers, from -infinity to +infinity. But the range here, the lowest point here, since this one keeps going down, is from the -infinity, and the highest point now is 0, 0 bracket. Okay, as simple as that one. Okay, the technique For graphing an absolute value, going back to the parent function, you start at the origin there, and then the technique is called the 1-1. You go up 1 over 1, you go up 1 over 1, and then reflection on the other side. Okay? And then if you are required to take a table, you can just identify these points here. Okay? Like this point here, it's -2, +2. This one here is -1, 1. This is 0, 0. This 1, 1, and this is 2, 2. Just plug in this coordinates on the table. Or you can start on the table, whichever works for you. I'm just giving you multiple ways, and whatever suit your, whatever you understand here, I'll take that one as long as you graph it accurately. Okay, let's go ahead now. So here are the technique in vertical and horizontal transformation. Again, when you say transformation, this is the movement sideways or vertically of the graph of absolute value function. So we already know that if it's y is equal to absolute value of x, it's like a V shape. It goes up, start from the origin, go up 1 over 1, up 1 over 1, up 1 over 1, and then do the reflection on the other side. Okay, so just like the rise over run, you go up 1 over 1. Okay, you connect those. Okay, so that's a y equals absolute value of x. Now, what if we have y is equal to absolute value of x minus 2? Okay, most of the kids knows that -2 is on the left or on the bottom part of the y value. Okay, here's the thing. Whatever is inside, this -2 is inside, that means it goes sideways. Okay, what I'm trying to say, if you have y is equal to x minus h plus k, this should be the format. The h tells you how much it will move sideways. The k tells you to move vertically. So this is not sideways. This can be done horizontally. Okay. So sorry for that. So when we have horizontal, when we have a -2 here, since that's negative, you do the reverse. You go to the right 2. So you go up 1 over 1, up 1 over 1, reflection, reflection goes this way. Okay. Why is it so? Here's what you need to do. You just grab that x minus 2 there and always set it equal to 0. When you solve for the x there, that will give you x equals 2. That's why you start at +2. So on the other way, so if we have y is equal to x plus 4, where do you think is the graph going to go? You're right, the +4 is inside, so you go sideways, but where? Do you go to the left or to go to the right? Since +4 is opposite, you go to the -4. Because x plus 4 equal to 0, so for the x there will be -4, so you start at -4. Up 1 over 1, up 1 over 1, reflection, connect them. There you go. Okay, so in other words, if I can raise that one, if you are given y is equal to x plus 2, oh no, let's change it, plus 5, this will go left 5. If you're given y is equal to x minus 6, you're going to go right 6. If you're given y is equal to x plus 7, you're going to go left 7. If you're given y is equal to x minus 8, you're going to go right 8 units. That's the horizontal transformation. But when you're given y is equal to absolute value of x, and then this time plus k, the k is a number outside the absolute value. This is the vertical transformation. So if you're given y is equal to absolute value of x plus 2, now your v shape will go up by 2 units because it's positive. If you notice, we're not reversing the sign. We'll keep it as plus 2. So you're going to go 1, 2, and then 1 up, 1 over, 1 up, 1 over, reflection, reflection, and then just connect them, and that's the graph of this equation here. So on the other way, if it's y is equal to absolute value of x minus 5, what do you think will happen? the V shape will go down 5 from the origin. So 1, 2, 3, 4, 5, and then one up, one over, one up, one over, reflection, reflection, connect them, kaboom. Okay? So if we try to flip things over, we say y is equal to negative absolute value of x plus 2. Take note, there are two transformations involved here. One, you're going to add 2 outside, so that means you're going to go up by 2. But there's a negative outside the absolute value, that means it's gonna flip over. So the graph of this one is gonna go up by 2, but same vertex there, but you're gonna go down one, left one, and then reflection, reflection. So the V shapes is same thing, but it opens downward because of the negative. So if we have y is equal to negative absolute value of x plus 5, this time the positive 5 is inside, so it goes sideways, but that's positive. You do the opposite, so where do we go? We go to the left. So let me erase this one here. We go to the left 5, and then that's our one, that's our vertex. Then we do the opening downward, down one, down one, left one, reflection, reflection, connect them. Okay, as simple as that one. All right. So again, what if they are combined? The transformation, the vertical and horizontal. Okay. So what if we have y is equal to absolute value of x plus 4 plus 4? Okay. So first, let's analyze inside. That's x plus 4. That is going to the left 4 here, but stop, that's not your vertex because you have another transformation here. It's positive 4 outside. That means you're going to go up 4. Boom. So that point there is your vertex. And then you're going to go up 1 over 1, up 1 over 1, reflection, reflection, connect them, and that's your graph. Okay, sorry, it's kind of crooked there, but you will just connect them, and that's the graph there. Okay, so what if you have y is equal to, as of, let's have a negative there, x minus 3 and minus 5 there. So here we're gonna first deal with the sideways minus 3. That means you're gonna go to the right 3, but that's not our vertex yet. There's a minus 5 here, so you're gonna go down by 5. 1, 2, 3, 4, 5. So that black point is your vertex. Since this one here is negative outside the absolute value, that means you're gonna open downward, down one, left, reflection, reflection, connect them, kaboom. Okay, that's how the vertical transformation and horizontal works. Okay, what if there's a number outside? Let's say you have 2 as a value of x plus 3. Okay, so again, this is x plus 3, that's sideways, so we're gonna go to the left 3. Okay, that's negative 3, and there's no number outside, there's no plus or minus right here. That means there's no vertical shifting, so the vertex there is 0, negative 3. But look, there's a 2 outside the absolute value. So what's the meaning of that one? It's kind of like a slope. If you remember, the slope is rise over run. Okay, so the meaning of that one, from the vertex here, you're gonna go up by 2 over 1. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. And then reflection on the other side, reflection, reflection, and then just simply connect, connect them, kaboom. Okay, so all you have to do there. So if you have y is equal to negative 1/3 absolute value of x minus 1. So here, let's have a plus 2 here. So we're going to start at sideways, which is negative 1. We're going to go right 1. The plus 2 tells you to go up 2. That's the vertex. Since the slope here is negative 1/3, okay, so down 1, right 3. Down 1, right 3. And then on the other end, down 1, left 3. Down 1, left 3. Okay, and just simply connect them, boom. Okay, as simple as that one, kaboom. Okay, all right, let's go now to a different way. What if we're using a table of values, and also if you have a coefficient beside the x, okay? So this is a different one, all right? kind of similar but slightly different. So let's read this step. So to create a table value, it's best to place the vertex in the middle, then include the values on both sides. So in this case here, we're going to do some computation. So how do we do it? The first one is find the x value of the vertex. And how do we do that one? Set the expression from the inside of the absolute value bars equal to 0 and solve it. So for this case here, this is the expression inside the absolute value. I'm going to set it equal to 0 and then solve for the x. So it will be 2x equals 6. So therefore, x equals to 3. And it says here, put it somewhere in the middle. So I can put it probably over here. That's 3 there. Okay. That's x value. Place this value in the middle row of your table. Okay. Number up and down, then complete the table. So let's pick the numbers on the left side of 3. 2, 1, 0, and on the right 4, 5, 6. Okay. Now, then graph it. So before you graph it there, you have to solve for the values of y here. So you're gonna plug in 0, 0 goes here. What's 2 times 0? So imagine you put the 0 here. 2 times 0 is going to be 0 minus 6 is going to be negative 6. And absolute value of negative 6 is positive 6. 1. 2 times 1 is 2 minus 6 negative 4. Absolute value of negative 4 is 4. And 2 times 2 is 4. 4 minus 6 is negative 2. Absolute value of that one is 2. Can you see any pattern? 6, 4, 2. Okay, that should give you an idea. But when you plug in the 3, which is your vertex, 2 times 3 is going to be 6. Minus 6 is 0. So absolute value of that is 0. And then 4 again here. 4 times 2 is going to be 8. 8 minus 6 is 2. So it's going to be 2, 4, 6, which is just a repetition of this one here. Okay, see the pattern there? Okay, so I'm gonna plot the 3, 0, which is right here. 4, 2, 5, 5, 4, and 6, 6. And reflection on the other side. Boom. The graph is right there. What's the domain range here? Domain here, this goes to the left, this goes to the right. So all real numbers are from negative infinity to positive infinity. The range there, again, you look at the y value. This is negative 10, that's negative 4, negative 3, negative 2, negative 2, negative 1, 0. This one is 0 here. That's 0. So from 0 going up, so bracket 0 to the infinity. Or you can say y is greater than or equal to 0. Okay? So let's do it one more here, this time with the fraction and with the negative and with the vertical transformation. Okay, so again, the first step here is set it equal to 1 half x minus 4 is equal to 0. Okay, whatever the expression on your absolute value, set that equal to 0 and then solve it. So I'm going to solve, move this negative 4 there. So it becomes 1 half x equals 4. X there is multiply everything by 2. X equal to 8. So 8, I'm going to put it, this is the x and this is the y. I'll put the 8 here. Okay. And then I'm going to solve. I'm going to plug in the 8 to the problem there, to the equation. 8 times 1 half, so it will be negative 1 half times 8 minus 4, absolute value, negative 2. 1 half times 8 is going to be 4. 4 minus 4 is 0, but there's an absolute value of negative outside, so this will be negative 0 or 0 still, minus 2 will become negative 2. Okay, you can use your calculator for that one, that's fine with me. Then you know that you have to get the numbers above and below 8. So I'm going to put here 7, 6, 5. And here I'm going to have 9, 10, 11. Okay, that's good, you know. All right, so we're going to plug in since I have here a fraction here, a 1 half. Okay, I can use calculator there. So 5 times 1 half. So 1 half times 5 minus 4 minus 2. Okay, you can use a calculator there. So 5 times 1 half will be 2.5. Okay, So 5 times point 0.5 is 2.5 minus 4 will give me negative 1.5 absolute value. And then absolute value of negative 1.5 is still, it's going to be 1.5, but there's a negative outside. So negative 1.5 minus 2 will be negative 3.5. 6 6 times 1 half, so negative 1 half times 6 minus 4 minus 2. This will give me a 3. 3 minus 4 is negative 1. Absolute value of negative 1 is positive 1, but there's a negative. So going to be negative 1 minus 2 is going to be negative 3, right? And then let's try 7. 7 times half is 3.5. Okay, let's do it here. Negative 1 half times 7 minus 4 minus 2. This will be 3.5 minus 4 is going to be negative zero point 0.5. And then absolute value of zero point 0.5 is positive zero point 0.5. But there's still a negative there. Minus 2 will be negative 2.5. Okay, you will see a pattern here that I showed you a while ago. So this will be also negative 2.5 from here, and this will be negative 3 also, and this is negative 3.5. That's a technique there. Okay, so when you graph it, so let's start with the vertex 8 negative 2, 8 negative 2 is right here, and then 9 2.5, so it's going to be lower here. 10 is negative 3 here. I don't have space for 3. Reflection, reflection, reflection. So the graph will be something like this. Okay, there you go. All right, and the domain here is go to the left and right. It's going to be all real numbers. The range, if you notice this going down, this going down. So the lowest point is negative infinity. The highest point here is negative 2. So that's from the negative infinity to positive 2 close. All right. All right, there you go. One last year, we're going to do the piecewise function. This time it's a combination of two. So we have learned already how to do piecewise, and we have learned already how to graph piecewise with linear and constant. Now we're gonna mix it up with absolute value. Okay. So if you have piecewise of negative 2x plus 1, that with the interval of x less than 4. So we graph that one. That's the same thing as y is equal to negative 2x plus 1. So the slope, the y-intercept there is 1 here. The slope is negative 2. So down 2, left 1. No, 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 sorry. Down 2, right 1, down 2, right 1, down 2, right 1. Or you can go up 2, left 1, up 2, left 1, up 2, left 1. As much as you want it, okay? But as long as you follow the interval says here, everything on the left of 4. So I'm going to keep going here down 2 over 1. Okay, that's the 4 there. Okay, that's the 4. So I can stop there because they said the interval is x less than 4. So everything on the left of 4. So the graph will be this here, arrowheads here because it's going to the left. And the 4 there is open. Look at here, it's open here. Okay, so this will be open right there. Okay. And the absolute value of x minus 3 if x greater than or equal to 4. So again, we learned this one from the technique or a table that this graph will be x minus 3 is equal to 0. So x equal to 3 there. So that means you're going to go right 3. And then you're going to make your 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, or reflection, reflection, reflection. But again, we only need everything from 4 to the right. 4 is right here. So everything here going that way only, and we can erase these points. We don't need that one. And boom, that is our piecewise involving absolute value and linear. Okay. And again, I hope you learn something about graphing absolute value. And as always, kaboom.